It's setting it up. Okay, that's working. Okay, great. And so now I will start the webinar. Oh, it's still 11:29. Oh, yeah, I'll start it. Okay, and now we can see attendees are coming in the door.
And we are live now.
Yes, we are. Everyone's taking their seat, saying hello.
Welcome, everyone. If you're just joining us, you are joining session 3 today. We'll be getting started in just a moment. We'll wait a few minutes for more folks to join the session. And it looks like we have a critical mass of people already at this point, so I think we'll go ahead and get started.
Great.
Again, welcome everyone. If you're just joining us, you're here in session 3 today of the CUNY conference. I'm Katie Schuler, and I'm going to be serving as your session chair. Before we start, just a few reminders. If you have a question for a speaker, there's a couple of ways you can ask. You can send it at any time by pressing the Q&A button in your Zoom. You can let me know if you would like me to read the question. You can say to be read or ask me to read it in another way through your Q&A. Or you can be called on by name if you'd like to read it aloud yourself, and someone will unmute you when I call on you, so you can ask your question and interact with the speakers that way. Okay, so let's go ahead and get started. So I am overjoyed to be welcoming Anne Kristoff with us today. Anne is a professor and director of the Laboratory of Cognitive Science and Psycholinguistics at the École Normale. She's a leading expert in the study of language acquisition, particularly in how babies and young children acquire aspects of their native language. She is especially well known for her work on the relationship between early lexical and syntactic acquisition, some of which she's going to tell us about today in our session. And not only is her work very theoretically strong, she's also widely regarded as an expert on research methods for one of our most challenging members of the population, infants. In her work, she makes use of a variety of really truly innovative methods that allow her to capture real-time measures in both babies and very young children, including eye tracking and EEG. Her recent work in child language acquisition makes connections to parsing, grammar learning, and reference in ways that are of particular interest to all of you, the CUNY audience, including, for example, some recent work examining how infants and children learn the meaning of novel function words and respond to these terms in running speech for parsing and interpretation. She is a world-renowned researcher who's received numerous awards, including most notably the Scientific Excellence Award and the Bronze Medal from the French National Center for Scientific Research. So please join me in welcoming Anne.
Thank you very much. It's a pleasure to be here with you, even if only just virtually. I hope that everybody can see my screen now. So I'm going to tell you today about bootstrapping the syntactic bootstrapper. Okay, so what does this mean? The question really, oh, sorry, it looks like this is not moving forward. I'm sorry, we tried this before. I'll just do it again. Okay. Now it's working. Okay. So the question is really, how do babies acquire word meanings? And when we think about word meanings, I like the way Lightmine is thinking about this. And really the idea is that words take their meaning in context. So it's pretty difficult to figure out the meaning of a word in isolation. And you notice that, for instance, when your children ask you, oh, what does this word mean, either in your language or in a second language. And quite often you're a bit stumped to answer a question like that. Basically, you say, oh, could you read me the sentence where you found that word? Or could you tell me in what context you found the word? And as soon as you get the context, then you can explain what the word means and give examples and everything. And also you see it in the fact that nowadays we tend to use online dictionaries. And when you you find the meaning of a word online. So you get this definition, which doesn't help you that much usually. And then you get a bunch of examples of good usages of that word. And that's really where you start to triangulate the meaning of the word. So really kids are doing that too. They processing words in context. And Lilac Lightman, now a while back, 1990, she put forward the syntactic bootstrapping hypothesis, which was at the time very controversial, and said basically that in order to guess the meaning of words, kids might rely on the syntax of the sentences in which they heard these words. So a good example is this distinction between thought verbs and transfer verbs. So if you have a thought verb like think, it's going to be very happy in a sentence like, I think that he will come tomorrow, where you have a whole complement, a whole sentence as the complement of think. And a transfer verb like give will be very happy in a sentence like, I gave a book to John, where you have three arguments: the person who gives, the thing that is given, and the person to whom the thing is given. And you see that you cannot exchange these two verbs. You cannot say, I gave that he will come tomorrow, or I think a book to John. If you try to make sense of a sentence like the last one, I think a book to John, it would work only in a parallel world where you can do a telekinesis, and it would mean I transferred a book to John using the power of my thought. Okay, and so these examples illustrate very clearly the intuition, the genius intuition that Lila had, that the syntactic structure of the sentence contributes to the meaning of the words that are in that sentence. And so the question that this work raises, and of course there were numerous experiments showing that indeed quite young kids start doing these things. Okay, so using the syntactic structures in which they hear novel words to try to figure out the possible meaning of these words. And so the question this hypothesis raises is how kids do to acquire the beginnings of syntactic structure, right? So if they're going to use syntactic structure to learn word meanings, they need to be able to learn that first. And so people have worked a lot on two aspects of speech, phrasal, prosody, and function words. And the reason is that these two aspects of speech are known to be available to very young infants. So for phrasal prosody, there's a wealth of experimental work by Peter Yushi, Kati Hirschpasek, Luan Gurken, and many, many others, showing that very young children, already from 4 months of age, are able to parse the continuous speech stream into prosodic units. Okay. And the other important aspect is the function words. So that's function words and morphemes, I should say, depending on the languages mostly. That's the articles, auxiliaries, all the little words that are highly frequent and also occur in a very specific distributional pattern. So they tend to occur at the edges of the syntactic phrases, and they also tend to occur at the edges of the prosodic phrases. So in that case, we have all the work by Luan Gurken, Rushenshi, and many others, showing that young kids already like 8 months old know something about the function words of their language. And so to give you a concrete example, having these two informations together, sources of information together, may allow you to build the beginnings of a syntactic structure, like a syntactic skeleton. So if we take a concrete example, like the little boy is eating an apple, if you speak slowly enough, you're going to parse this into 3 prosodic units. The little boy is eating an apple. And in blue, I've put these highly frequent function words and morphemes that occur at the edges. And in fact, if children manage to figure out that the co-occurs typically with nouns, and an impoverished structure like this, which is nothing like a real syntactic structure, we agree, might be sufficient for them to figure out that in this first prosodic unit, even if they don't know words like little and boy yet, they can expect to find a noun in there. Okay, so now how can we test whether children indeed do something like that? So the first experiment I wanted to present to you today is one indeed showing that kids recognize words in context. So there's already some experiments showing that 18 months old use the context to process words faster. So these experiments show 2 pictures to a child, let's say a dog and a ball, and then they ask them to look at one of them. For instance, look at the dog. And if you do that, you see that the kids go faster towards the dog picture than if you give a sentence that is incomplete. For instance, look at dog, where you just have a silence instead of the article. Okay. And so together with this kind of experiment showing that kids process words in context, we also have a very counterintuitive result that was obtained by Dan Swingley together with Dick Aslin, published in 2007. And this showed that 18 months old, who are really very good at phonological processing at that age, cannot be made to learn a novel word such as tog. And the reason seems to be that tog is too close to dog, and they already have a meaning for dog, okay? So if you take a new animal, let's say a funny dinosaur, and you try to teach them this is a tog, the kids don't learn, they're confused. And so this was very disturbing for a while because we know that kids can hear the difference between the and t, okay? And what would be the point of hearing these differences if you're not going to use them in order to figure out that something is a novel word, okay? So when we thought about this and discussed it with Dan as well, we had this idea that perhaps the reason why kids were confused is not because they were not sufficiently sophisticated listeners. It's rather because they were highly sophisticated statisticians. So now if you think of an 18-month-old and think about this whole phonological space of words, where words could go, okay? And in an 18-month-old, it's still quite sparsely populated. They don't know very many words, okay? So they know dog and baby and bottle, and these words are very distant from one another. So now think about the probability that a novel word, such as tog, falls just very close to dog that they already know. Well, actually, that probability is pretty low. And kids, being good statisticians, realize that this is a low probability and probably start thinking too much about what this dog word might be. Maybe it's just a variation of dog, or maybe they have the wrong meaning for dog actually, okay? And so we wanted to figure out how refined the kids taking into account of context was. And to do that, we decided to change the syntactic category of the neighbor. So this is how it goes. We have the example of dog and tog, okay? So here, dog is a noun and tog is used as a noun as well. We said, look at the tog, okay? And we thought that if now we take a verb that kids know, like give, for instance, and we modify this minimally, like a give, then they might not be as confused because if you say, look at the give, that's a context where you would never find the word give. Okay, so the idea basically would be that kids would have that space for, let's say, nouns and things that occur in noun context. And maybe there's a parallel plane where you could have the verbs. And kids wouldn't mind if one is close to the other phonologically, so long as they belong to different planes. So in that experiment, the kids were watching a video like this, which I'm not going to play because sound is not working, but that's okay. And so basically they see a lady playing with this funny novel animal and naming it 10 times and looking at it, pointing at it. So giving them many, many clues that the novel word was the name of that novel animal. And we have these two conditions, as I said before. So the noun neighbor, here un canard, which would be equivalent to a tog, and the verb neighbor, so something very close to a verb they know. And here you get the results. So in red, you have the curve for the results for the noun neighbor. If you remain around 50%, there are just two pictures to look at. It means that you're at chance, okay? If you go above 50%, you look at the correct picture. And you see that the kids remain around 50% for the noun neighbor. So we replicate nicely the study by Dan Swingley, and Swingley is a collaborator in that study, of course. And in blue, you see the results for the verb neighbor. So they are not bothered at all by the phonological similarity between a verb they know and this novel noun that we asked them to learn. And in fact, so Isabelle d'Autriche, who was doing this work for her PhD, she figured out that maybe we could go one step further. So in fact, if really we have these two separate planes, you could even teach kids novel homophones. And that's what she did exactly. So she took the exact form of a verb and used that to teach them a novel noun. And this is the result. So you find here the green line. The kids learn perfectly well that this thing that sounds exactly like a word they already know, but a verb, could be the name of a novel animal, and they don't mind at all. So this is a very nice result because we know that languages are full of homophones. We also know that adults typically don't notice these homophones. Well, kids are the same. They don't notice the homophones because they process the words in context. Okay. And this was a pre-registered study. Okay. So these results show us that infants already at 18 or 20 months are sensitive to the syntactic context of words. And we know that a few months later, they exploit this syntactic context in order to figure out whether a word is more likely to refer to an object or to an action. But in real life, you don't always have a nice and ambiguous function word just before the word you're trying to learn, okay? So you could have sentences like these where you get, do you see the baby blicks? Or do you see the baby blicks? And in that case, you have this novel word blicks. In the first sentence, it's actually a novel noun, and we're talking about a new category of stuff, the blicks, and these are baby blicks. In the second one, it becomes a verb. And this just because of the syntactic structure of the sentence that is reflected in the prosodic structure in that case. So the question is whether children can also use both phrasal, prosody, and function words in order to figure out the likely syntactic category of a word. So these experiments were performed by Alex de Carvalho during his PhD. So here's one. This one is with homophones in French, such as souris. So souris can mean either mouse, when it's used as a noun, or to smile when it's used as a verb. And so if you have a sentence like regarde le bébé souris, then it means look at the baby mouse. And kids who were listening to sentences like this indeed looked more at the mouse than at the baby smiling. That's what you see in the red curve. Okay, it goes higher towards the mouse. In contrast, if you tell them regarde le bébé sourit, then they look more at the baby smiling. Okay, so 20 months old already can use this combination of function words and phrasal prosody to figure out whether they're listening to a noun or to a verb. Can they do that with novel words? Well, this is another experiment, again with Alex de Carvalho, this time in a collaboration with Angela Hay and Jeff Leeds. We used an extremely clever design that they had invented just before. And this is a design relying on habituation. So in that design, the children see only one video at a time. So it is simpler than showing them a choice between two videos, which is typically too hard for children of that age. And so they see these two videos, one after the other, and we teach them two novel words for this video. So with the first video, they're going to learn a new verb, here, dorip. So they see this penguin doing this very strange cartwheeling action. And meanwhile, they're learning this novel word, it's doriping, okay? And then when they finished looking at this one, we show them a second video. Now they see the same penguin spinning and they learn a new noun on this one, okay? So they learn that this one is called a bamoul, c'est une bamoul. Sorry, I have trouble with that. That's okay, it's just spinning and they hear it's a bamoul, okay? So we adults, when we watch a video like this and we hear a novel word like that, if we hear a novel verb, we infer that it likely refers to the action. And in that case, doriping should mean cartwheeling, okay? And when we get the second one, so again, we have this penguin doing an action, we hear a novel noun, so the likely inference is that bamoul means penguin. And that's what adults would do. If you want to test how the kids would, whether the kids would make the same inferences, well, the very clever idea that Jeff Leeds and Angela Hay had was to simply exchange the soundtracks of the two videos. So now, when you look at this penguin cartwheeling, you hear it's a bamoul. If you learn that bamoul means penguin, then you still have a penguin over there. Everything is fine, and you shouldn't be surprised. And when they're watching this penguin spinning, now they hear it's doriping. So the situation here is different. If they learn that doriping means cartwheeling, then they should be surprised to now hear that this penguin is doriping when it is not cartwheeling anymore. Okay, it is spinning. So we predict that the kids in this group should not be surprised. They should find it perfectly fine. And the kids in this group should be surprised. And this is exactly what we find in the results. So here you have the mean looking time in seconds for the last two trials of the habituation in blue and for the two test trials in yellow. And you see indeed that the group who has the noun switch condition has no difference between the habituation and test, whereas the kids in the verb switch condition increase their attention at test as if they were surprised by this verb switch. Okay, So this suggests that they interpret these just like the adults. They interpreted the novel verb as referring to the novel action. And can they do that too with only prosody? So now this is exactly similar to the souris experiment that you just saw, homophonous between mouse and smile. Now this is with non-words. So they see the penguin cartwheeling and they hear "Regarde la petite Doripe." In that case, this would be interpreted as a verb by French adults. And with the penguin spinning, they hear "Regarde la petite Bamoule," and this one would be interpreted as a noun by French adults. The design is exactly the same, and the results are exactly the same as well. So you see that the kids from the verb switch here show surprise. They increase their looking relative to the kids from the noun switch group here, who don't increase their looking. Okay, so far what I've shown you is that basically these 18-month-old are geniuses, okay? They've learned a lot already about the context of nouns and verbs in their language, and they can use what they've learned in order to figure out the meaning of novel content words. But we still want to know, how did they learn, right? How did they manage to learn this noun and verb context? That's the question we were after to start with, remember? So here's the hypothesis. We hypothesize that children might do this by using a semantic seed. And by this, we mean a few nouns and verbs for which they manage to learn the meaning just by looking around them, okay, just by looking at the visual context. So we're thinking that if they manage to learn the meaning of a few highly frequent nouns and verbs that represent concrete objects and actions, then they might use this to learn in which context these words occur. And in fact, we know that this is a plausible hypothesis because of the work by Elika Bergelson and Dan Swingley, showing that already 6-month-old know a few nouns, and 9-month-old already know a few nouns and a few verbs. Okay? So by the age of 10 months, you can very well assume that the kids have learned some nouns and some verbs and could use them in order to learn in which context they occur. The other assumption we need for this to work is that kids should be able to group words representing objects together and group words representing actions together. And that too is quite plausible, and it's summarized in the work by Sue Carey in 2009. Okay, so how can we test this? In that case, this is a model, a pretty stupid model, a very simple one, that is trained on a corpus of child-directed speech. And in this corpus of child-directed speech, we try to model a child who has managed to learn a few nouns and verbs already. So we take the most frequent nouns of the corpus, we select those that refer to concrete objects, and we assume that these are known by the child. We start with a very small vocabulary, in that case, 8 nouns and 1 verb, and then we increase it little by little to see whether it helps to know more words. Then what the model does, again, very stupid, it just collects trigram frequencies, so lists of 3 words, and we'll remember that. So for instance, if baby is part of the semantic seed, if it is one of the words they know, and we assume it because it's a very frequent word, then if they hear a sentence like, so beginning of sentence and then baby, they will remember this string of 3 elements, right? And they know that baby is a noun. After they've gone through the training corpus and memorized all these triplets of words, we present the model with a novel test corpus. And in this novel test corpus, the model stops on every word that is not too frequent. This is just to get rid of the function word, and looks at its immediate context. In that case, the 2 words just before it. Okay, so that would be beginning of sentence and for this sentence, the cat sleeps. And then as a response, it will select the thing that occurred most frequently in this context. So it could either be a category. So let's say that in this context, we found most often things that the model knew was nouns. Okay, then the model would say, oh, I think that should be a noun. Or in some cases, it might reply with a specific item. So let's assume that by a funny property of the training corpus, in that context, the model found mostly the word tiger. Then the model will say, I think that this thing is tiger, and we will count it as a mistake, okay? And then to figure out how good the model is doing, we compute 2 things like the usual ones, precision is hits divided by hits plus false alarms. And it tells you basically whenever the model gives a noun response, is it correct or not? So high precision means that the model finds nouns correctly. Low precision, it means that it gives a lot of noun responses that are not really nouns. And recall that hits divided by hits plus misses. And that tells you how many nouns the model found. So if recall is high, the model found most of the noun. If recall is low, the model didn't find most of the nouns. There are many nouns that were missed. Okay. So here you get the results. This is work that was done by Perrine Brusini and Olga Semank. So you get the precision on the top graph, the recall on the bottom graphs. On the left, you have the nouns. On the right, you have the verbs. And here in the x-axis, you get the size of the vocabulary. So V0 here is only 8 nouns and 1 verb. V1 is slightly bigger, and so on. And you see two interesting things. The first one is that precision is extremely high, both for nouns and for verbs. You see here that whatever the size of the vocabulary, the model correctly categorizes nouns, so about 90% precision, which is very high. And for verbs, you see that we remain over 80% throughout. The recall, in contrast, starts pretty low. So we find here that when the model knows only a few words to start with, it doesn't learn many contexts, and there are many words that it is then not able to categorize at tests. But the contexts that were learned are good contexts. Okay, so this is really a good situation for a learning baby. You don't learn, so there are cases where you don't know what to do, but when you make an assumption that this should be a noun, then you're usually correct. Okay, this is the best possible situation. So what this very simple model shows us is first that it categorizes words in context, and therefore it is not bothered by homophones, just like children. Okay, that's good to know. The semantic seed is highly efficient. So we compare this with other models, which are trying to be completely unsupervised, all right, no information whatsoever to start with. They run in a number of problems. So having a little bit of information to start with to seed the categories is highly efficient. And the third interesting property of this model is that when you look at the context at work, they contain mostly functional items. Okay, so good context for nouns will contain articles typically in French. And that's just because of the very high frequency. So what this simple model tells us is that this is indeed a plausible mechanism. Children could do it that way because the information is there in the signal, okay? But do they really do it that way? How can we test that? So in order to test something like that, now we're trying to figure out by what mechanisms kids learn something. We can't just go on with looking at what they learned about their native language, right? Because then we never know how they managed to learn this. We can just say, at this stage, this is what they managed to learn. So we need to teach them new syntactic context, and that means new function words. And now there's really two ways to go about this. One would be to teach them an entire new language. And people have tried, like for instance, Carla Hudson-Cam and Lisa Newport did this with like 5-year-olds. But this takes weeks, right? If you're going to teach them an entire artificial language, either it's really simple or it's a bit complex, and then it takes a long time to learn. Or you could do something else, and that's what we chose to do. By the way, I should say this is an experiment that was invented together with John Truswell when he was visiting in Paris. What we decided to do is to teach them pseudo French. So we're going to take French, almost perfect French, and then add just one novel element. In that case, one novel function word. We called it co because it's a short one. It's a plausible function word, but it sounds nothing like function words in French. And so this novel functional element, there were two conditions in this experiment. For kids in the verb condition, we replaced all personal pronouns by this co-element. So the kids were watching a video where I was playing with toys. There was this whole story like, it's a turtle. She looks at a book. Now she's going to play with something else. She plays with a big pig. And in the verb condition, all the she's and it and he were replaced by co. Like, it's a turtle. Co looks at a book. Now co is going to play with something else. Co plays with the big pig, okay? And for the noun condition, it replaced all articles. So it would be something like, it's co turtle. She's looking at co book. Now she's going to play with something else. She plays with co big pig, and so on, okay? And then after they look at this thing, so this is just like a 10 minutes video, right? It's not very long. Then we move to the test phase. And here they get a choice between these two videos. So in one of them, they see this lady performing a novel action. It's something like this. And in the second one, they see this other lady showing them a novel object and looking at it, okay? And they hear this thing like, oh, look, codas. Do you see codas? And so in order to figure out what this novel word might mean, what is the best possible meaning, they have only information from this function word co here. And the hope was that kids from the verb condition might think, oh, co here is followed by a word I don't know. But in my experience, co was followed by verbs that I knew. So maybe co is also referring to an action. And the kids from the noun condition should think, oh, co was followed by nouns, and therefore it's also likely a noun here and probably refers to an object. And again, a pre-registered experiment. So this is exactly what we found here. I'm going to show you here the proportion of looks toward the novel action video. Okay, so when the curve goes up, they look more at the novel action. If it goes down, they look more at the novel object here. And what Mireille Babineau, who is doing this work, found is that when you ask them codas, the group, the kids from the verb condition here in this time window look more at the novel action compared to the kids in the noun condition, okay? And so in order to, well, the analysis here was a cluster-based permutation analysis. So it's just to figure, to find
We seem to have lost the connection with Anne. We'll try to connect back up, hopefully soon. So please bear with us. I'm gonna mute myself again.
While we're waiting, you might use this time to think of your questions and submit them to the Q&A.
Anne seems to have left the meeting, probably due to connection issues.
Thanks for your patience, everyone. I'm sure she'll be joining us in just another moment or two.
Alex, if you're here, can you?
Yes, I just called her. She's
Okay.
trying to connect again.
Okay, good. Alex is in Paris as well, so
I'm back. I don't know if you can hear me.
Oh, she's back.
yay!
Hooray!
I'm
Okay.
very sorry. My connection was bad. So I'll share the screen again. I'm sorry. I'll skip a few slides to.
Oh, it's okay. I think you can start where you left
where I
off.
was.
Yes.
Okay. So we finished with that core experiment, right? I was then going to tell you about another experiment because for two reasons. Well, this one is with kids who are a bit old, so the 3 to 4 year olds, but also because in that case, you could solve that learning question with metalinguistic abilities. Like you could think, oh, I think that core replaces all articles. So this is very, very metalinguistic, of course, but the kids could still learn, oh, whenever I get co, it means either the or a. Okay, so they could like replace it in their head with the corresponding functional elements in their native language. And that wouldn't be quite the same thing that kids who learn their native language have to do, right? Because they have nothing to replace it with. So in this new experiment, we went younger and we used a distinction that doesn't exist in the kids' native language. So in that one, they learn not just one, but two function words. One is co, and the other one is ka. Okay, so they're very similar, like you often find. And so in this movie here, ko precedes all animate words like ko chicken and ko rabbit, and ka precedes all inanimates like ka book and ka tractor. And it's just like before, they hear this like 5 minutes video with the entertaining stories for young children. These are 20 months old. And before they come to the lab, they watch this video at home with their parents 3 times, okay? Because we know that sleeping on it helps learning. And then at tests, when they come to the lab, we present them with these two pictures. So one of an animate, a new animate, and one of an inanimate object, again, a new one. And as before, they get this instruction to look at either ko bamul, so a new word preceded by ko, or ka bamul, so a new word preceded by ka, okay? And the results here, as you can see, is that children, so now it's only one group of children, okay? So the children, when they hear a novel word preceded by ko, then they tend to look more at the animate picture than when they hear this novel word preceded by ka, in which case they look more towards the inanimate picture, okay? And this time window, again, is found with the cluster-based permutation analysis, okay, to figure out if there is any time window in this whole test trial where the two curves, red and green, are significantly different. So what this experiment tells us, and that was the work of Monica Barbier during her PhD thesis, is that in fact, young children, 20 months old, can use words they know in order to learn about novel functional elements that not only don't exist in their language, but correspond to nothing at all in their native language. Okay, so they can really form a novel functional category with new properties. In that case, animacy, which is, so we didn't choose that by chance, right? It's a property that is very often marked in the world's languages, but not in French, okay? Okay, so far we know, now I have no idea how much time I've left. We know that children are able to use the content words they know to learn the syntactic context, and then they're able to use this syntactic context to constrain the meaning of novel content words. Okay, and the question now is by what mechanism they do this? And basically, you could think of two different ways of doing that. One is that perhaps they go through a phase during which they gather knowledge about the grammatical structure of their language. They learn all these syntactic contexts, and then they use that knowledge. Or you could think of a way in which the two would be intertwined. So the learning and the processing, which I think is more plausible actually. And how would that work? Well, if you think of children a bit like adults, always attempting to predict what we come next, well, then they would project expectations onto the next word. When they get an unknown lexical item at that moment, then they could project the expected properties onto that novel word and then use it to learn something about that novel word. When they get a word they know and there is a mismatch between what they expect and what they get, then they will need to change their expectations, and that would mean revising their language model. And in that way, they would learn their language little by revising their language model. Okay, so how can we test that? The first thing is to figure out how kids react in presence of a mismatch. So here's one experiment by Marieke van Heugten, where we use the fact that, in French, there are different genders, so feminine or masculine. So here you have two words. This one is banane and the other one is bateau. Sorry, I've lost my mouse. This is banane and this is bateau. They start with the same syllable, ba. One is feminine, you say la banane, and the other one is masculine, you say le bateau. So when you get this and you hear, oh, regarde le, ba, then you could start looking at this one as soon as you get le, because it cannot possibly be this one, okay? So when the two pictures here correspond to words with the same gender, you should be forced to wait until the last syllable of the sentence. When they contain words with different genders, you should be able to anticipate and look to the correct object much earlier. And this is what Marieke found. So in dark red, you get the curve of looking at the correct picture in different gender trials when the article is informative. And in light red, you get cases where the two genders are identical and the article doesn't get you any useful information. And you see that they can go faster when they have useful gender information. And the manipulation here was to have a different group of subjects, of kids, with the exact same test trials. But now during the filler trials, we made that speaker use gender randomly. So we told them basically that speaker is not reliable relative to gender. And you see here that the difference between the two conditions disappear. So now they cannot use gender to anticipate correctly, and they just stop using it, they start ignoring it. So what this tells us is that when the speaker is not reliable, children and also adults stop relying on the syntactic context to anticipate upcoming words. So that would be consistent with this idea that you revise your language model, but it's not a proof because kids could just have done the same thing by adopting a wait and see strategy. Okay, and in that case, they would not have learned anything about this particular speaker, just learn to wait a bit before they commit. So how could we test this? For this, we got inspiration from an experiment by Jurovsky, Case, and Frank, who tried where they had two conditions and sentences that were semantically implausible, like I had carrots and bees for dinner, okay, where you would expect carrots and peas and not bees, okay. And in fact, the two groups of children, one of them heard a lot of sentences that were semantically implausible. So it was kind of trying to teach them, okay, this person is saying things that are semantically implausible. Therefore, you can use the literal meaning of the sentence. And another group had a lot of noise, and therefore they couldn't be very sure whether they heard peas or bees. And this group indeed went more towards the semantically plausible interpretation, thinking that probably they didn't hear correctly the critical word. So we tried to do the same thing in comparison between syntax and semantics. And this experiment is a bit complex. I'll walk you through it. So the idea here is to present children with things that are where there is a mismatch, such as elle pomme, which would be something like she apples. Okay. So in order to interpret something like this, you have two choices. Either you think that the person wanted to talk about apples and she used the wrong function word. Okay, that was a mistake. In that case, you should look for apples. And in this group here, the semantics reliable condition, they got a choice of pictures where there was an apple and there was nothing that could be a new action. So no possible referent for this novel verb apple if there was one. In the syntax reliable condition, in contrast, they got a novel action that would be a plausible referent for she apples, but they didn't get an apple, right? The distractor here was showing a shoe. And then at test, they were presenting with exactly the same kind of thing. For instance, here, elle balle, meaning she bowls. But now we gave them two plausible responses. So this is a good answer. That's a new action. It's a good answer if you trust the syntax. You think, oh, I think the function word is used correctly. This must be a novel verb. Therefore, that must be the novel action. And this one was good if you trusted the semantics of the content word. So if you take balle, you think, well, here there's a balle, and I would just ignore the pronoun here. And what we found is that the children, well, here we have adults and children, and in both cases we find the same result. So when they were induced to think that that person was using semantics correctly, then they chose the semantic choice more. So that's the red dots. Then when they thought that the person was using the syntax correctly, in which case they use the syntactic choice more. That's the green dots. And for this one, and that's the last experiment I'm presenting, I'll just show you quickly the looking time, the gaze patterns, because I think they're interesting. So here you see time flowing. So they can either look at the novel action if they go up, or the known object, here the ball, if they go down. You see here that when they hear she, they all start to go up, okay, whatever their condition. So they go towards a new action. Then they get this content word here, ball, ball, and they all go down to look at the ball, okay? So they really follow the words they hear. And then as the sentence unfolds, you see that they start bouncing back. And indeed, the syntax reliable group bounces back a bit faster than the semantics reliable group, which is exactly the kind of effect we were looking for here. In that case, none of the time windows show a significant difference between the two conditions because this is too noisy, right? This is not a strong enough effect. Okay. And I'll just conclude here. So I hope I showed you that children, like adults, process words in context, that when they learn the meaning of words, they don't just try to associate word forms with the things in the environment. It's really an inference process. They exploit the context in which the words occur, and that's not just a linguistic context, but also the visual scene, the speaker's intent, and so on. I've shown you that this idea of the semantic seed was very powerful to learn syntactic context, and that kids could use phrasal, prosody, and function words to build what I call the syntactic skeleton. So have some information about the syntactic structure of the sentence, although of course it's not a full-fledged syntactic structure. And all that might be enough to constrain the acquisition of word meanings. And finally, I tried to show you some more recent experiment about this idea that perhaps kids learn by always attempting to build expectations about what is coming next, and then using these expectations to compare them with what they get and learn their language in that way. Thank you very much.
Thank you so much, Anne, for your wonderful talk. Because we had a slight interruption, we're going to give the full 10 minutes for the question period. We'll just be on a slight delay. I'm sure no one will mind. I'm going to turn it over to the several questions that we have already. As a reminder, if you want to ask a question, you can do so in the Q&A. If you are logged in as a panelist, you can ask in the chat window. Let me know if you want to ask the question yourself or if you'd like me to read it aloud. I also want to pause for a moment and encourage any students or postdocs, if you have a question, please don't be shy, go ahead and ask. So our first question is from Jessie Snedeker. Jessie would like to ask the question herself.
There's the unmute button.
There you are.
And thank you so much. That was such a rich talk. I wanted to just close in on the model portion of it, right? This looks to me like basically an instantiation of semantic bootstrapping at the earliest phase. The child looks for conceptual categories, right? Objects, think words they know refer to objects, words they know refer to action. And then they essentially label those as syntactic categories, nouns or verbs, assuming that other things that are in that category might not actually have that semantic core. So that's semantic bootstrapping, which made me think a little bit about both how the semantic seed was created and whether it might be vulnerable or not vulnerable to some of the same arguments that were made about semantic bootstrapping in the first place, right? So a couple things occurred to me. I assume that when you chose your semantic seed, you actually put both of those filters on immediately. The only things that could be in the semantic seed had to meet both the conceptual category and the syntactic category, right? But that originally raises the question of homophones. How does a kid know that hammer is a noun is different from hammer is a verb? It also raises the question, I think, which was always a problem for semantic bootstrapping, of defining what an action is. We have a reasonable idea about what an object is, but I don't think anyone's ever come up with a really good story about what counts as an action. And then, of course, it also runs the problem syntactic bootstrapping raised about, do children really have the ability to learn, right, what action words refer to before they have the syntax? So maybe you can tell me a little bit about how you guys chose your semantic seed and whether you think it is vulnerable to those arguments.
Yeah, thanks a lot. These are very good questions. And indeed, I presented it in that way. I said, kids have to learn these words and they have to group them into categories. Actually, I'm not that sure that this is the most efficient way of learning, because you cannot know in advance which will be the good categories. And on the other hand, kids are working from rather small lexicon to start with, right? So if you think now about the experiment I presented with the animate and the inanimate objects, I think maybe a more plausible way of going about this is that what the kids memorize is exactly all the things that they heard in those contexts. And that's quite possible because they didn't hear that many things and they don't know that many things. And then what you would do when you do the inference work, when you try to figure out what might be properties of this new, what might be properties of the referent of that novel word I'm hearing, okay, which is what we're doing now, then maybe what you would do is, oh, I get this novel word, I'm going to figure out from all the list of things that I heard in this same context, do they have a property in common that I could then extract and attach to the novel word? So in answer to your question, and especially like the idea that it's not easy to build a category for actions, what I think is that perhaps kids are going with much finer grained categories to start with, and you escape the problem of how you build the finer grained categories because maybe you don't need an exact category. Actually, you could go with the exemplars, with the items you've heard. And by items, I mean not every single instance, but the fact that you heard the same word in different contexts. Is that clear?
Oh, it's clear. I would love to engage it further. The first thing that occurs to me, and I won't rush, but just there's that paper that Lila wrote, right? Called A Picture's Worth 1,000 Words, and that's the problem. And I feel like you got a combinatorial explosion. That's gonna be a radically different model, though it sounds really promising. Thank you.
Yeah, I don't think it would work very far, but at the very beginning, it might work actually, because they don't know many words.
Thank you.
Wonderful. Our next question is from Elika Bergelson. Elika would also like to ask the question herself. You should be able to unmute yourself momentarily.
Yes, thank you. I also really enjoyed the talk. Thanks, Anne. My question is about the Dorit Bamul studies and the level of specificity that kids are positing for the verb. So in your case, the story is that it's cartwheeling and spinning, and so it should be confusing if it switches. But if they had posited something a little bit more semantically blanched, like moving, then it shouldn't have been surprising, right? So I'm wondering what that means the implication is for learning verbs that are slightly less specific in what they're picking out, and like verbs like moving, which aren't even as semantically blanched as some other verbs are, right? But and how this also aligns with the timeline for familiar verb acquisition in the first place. So do we actually find that kids are learning more specific things, especially in a language like English and French? This might be a little different. But what are the implications of learning your familiar verbs and the level of specificity that kids seem to be positing after just this couple minutes of exposure to cartwheeling and spinning?
Yeah, you're very right. So when you look at a specific action and you hear a verb, it could be a bunch of things, right? It doesn't have to be that very specific action. What I guess what you measure in this dishabituation thing is just the level of surprise of the child. So basically, this would just say, "Oh, I heard this thing labeled that action, and now I hear the same thing labeling this action, which it is different, right?"
Right.
And so it could just be the time that they take in order to not just saying, "Oh, I'm very surprised. This is not what I thought." This might just be, "Oh, that's a new instance. I need to work it out into the meaning of that word." Okay, which is something that we all do. When you learn a new word, you hear it in one context and then another and then another, and you refine the meaning of that word as it goes. So in the case of the noun, there is no refining to do. It's the exact same penguin. Okay. In the case of the verb, you need to refine it. So you learn something and now you learn something new. Maybe it's all kinds of things that have to do with turning or whatever, you know. So maybe they're just taking some time to figure out what the real meaning of that verb is. But that's perfectly fine. I mean, it's still for what we were trying to say. So it still means that they're using the syntactic context of the word in order to figure out what the possible meaning is. So it's the same conclusion, but there might be a much more realistic learning procedure than just thinking, "Oh, this means exactly cartwheeling," and now, "Oh, I'm surprised because this is not cartwheeling," right? This could just be, I now need to integrate more information into the meaning of that novel word.
Gotcha. So you could have a prediction, like if you had cartwheeling happening a little bit slower, that might not be surprising because that might not be a new instance of a new kind of action, as opposed to something that's categorically, to us as verb havers, very different basic level action, something like that.
Yeah, I guess that would be a good prediction.
Gotcha. Thanks.
Thank you. Next up, we have Roger Levy. You also would like to ask the question yourself?
Hi, thank you, Anne. I concur. This is a very, very interesting and thought-provoking talk. Thank you very much. I'd like to ask just how sophisticated do you think that, I sort of want to ask, how sophisticated do you think the statistical knowledge of the lexicon is in children under 2 years? So you have this very nice results that show that children are sensitive to differences in syntactic category and also have expectations about how similar to other words a new word will be. And so you could sort of think of those as mostly about knowledge of the overall lexicon, but it's sort of getting a little bit into some kind of meta knowledge as well about the way the lexicon is overall likely to shape up. And I want to ask, how far do you think that knowledge goes, especially in children under 2 years? So as an example, you might expect that children under 2 years already know that there are a lot fewer function words than there are content words, and the function words are more frequent. And so a young child, even before 2 years, they might require more evidence to be convinced that they've encountered a new function word versus only a little bit of maybe one instance for a new content word. And once again, this would be a more sophisticated kind of meta knowledge of the structure of the lexicon. And I'm wondering what your view is about what's the extent of that sort of overall knowledge about how the lexicon is likely to turn out to be overall as the child continues to learn versus simply all I know is the words I got.
Yeah, that's a very good question. And actually there are some experiments about function versus content words. And the kind of experiment would be that you just expose children to a stream of syllables where some are highly frequent, like there's 2 of them and they repeat every other syllable, and others are used much less frequently. And then they present a pair of these syllables, a frequent one and an infrequent one. And this is like learning an entirely new language, okay? That was done by Jean-Rémy Hochman, by the way, with Italian kids, but this was not Italian. And then they showed that when you hear this pair of syllables paired with a new object, and then this is a bit complex, so you have these 2 syllables, one frequent, one infrequent. You take the frequent one and you pair it with another infrequent syllable. You take the infrequent one and you pair it with the other frequent syllable. And then you present one of these and you see which one of those 2 things kids attach to the word, to the object that they already learned. And you find that they attach the object to the infrequent syllable, as if they already knew that the frequent things, what we call the functional elements, are not those that will carry the meaning about these like concrete objects. Okay, so it seems that kids already have this kind of assumptions. And I don't know if you could find a way to get these things without any kind of innate structure, or whether you have to postulate that kids are expecting things to be frequent and others infrequent. But you might be able to just figure it out. Like you could say, this thing is so frequent, right? And you get you think, well, the can't possibly mean cat, right? Because I hear the lots of the time when there are no cats around, that kind of thing. So maybe kids could infer that the highly frequent things will not refer to specific things in the world.
Thank you.
Thanks so much. And so we're out of time for questions. There's a few more questions that we didn't get to. If you want to ask them, you can head on over to the discussion board available on the schedule to continue the conversation there. Thanks again, Anne. And now we'll turn it over to Alex. Alex, if you'd like to join, you can share your screen.
Yes, sure.
Hold on a sec.
Welcome, Alex. It's nice to see you.
Hi, thank you. Can you guys hear me well?
We can hear you great. So it's my pleasure to welcome our next speaker, Alex de Carvalho. We just heard a whole bunch of his existing work, and now we're going to hear something new. So take it away, Alex.
Okay, thank you very much. So yes, this is a new work that we did together with Victor Gomez and John True as well at Penn, and it's about negation and how preschoolers could use negative sentences to constrain their interpretation of novel word meanings, and especially how they associate meanings to novel words. So, okay, let me try to. So, okay, as you probably know, negation is a universal and abstract component of human language and thought. And as such, it's of great interest for understanding the relationship between cognitive and language development. As you just saw in Anne's talk, of course, children, when they are acquiring language, they need to get to know the words and combine words into sentences to figure out what we are talking about, right? But negation has a very abstract meaning because contrary to content words like cat, in which a direct link between the word form and a possible reference in the word is possible, if I ask you what's the meaning of a negative element such as not, you cannot give me an answer without knowing in which context that word has been used, right? So negation requires you to do some kind of computation, right? And even if I gave you a sentence like not a cat, it's hard to understand exactly what I'm talking about, right? So, and we know with adults that negation can sometimes be hard to process and to interpret. We know that in some circumstances, adults interpret negative sentences more slowly than affirmative sentences, right? But you could think, okay, well, that's a problem of adults, but actually no, because when we look at the input that's addressed, so the language that children hear in their everyday lives, we realize that approximately 8% of all the sentences in child direct speech, so for example, that's work that's being, that was done by Victor Gomez with John Truswell as well. So when we looked at in the child corpora, all the words that express negation in there, right? So we labeled all the sentences containing negation. We found that approximately 8% of all these sentences that children are hearing in their everyday life, so that's the corpora for children from 14 to 58 months of age, 8% has negation. So, and we also know from previous studies that negative elements that are used frequently by parents are those who appear first in their child production, right? So that we need to understand what's going on with negation in children, and that's not a particular new question, because a lot of people, especially from the 70s, like Louise Bloom, have investigated how and when children learn the various uses and forms of negation by investigating the context in which negation appears, right? So basically in which context the children would hear negative sentences and what are the meanings that they have for negation, right? And what has been shown is that kids, they can use negation to refuse things, right? So they can say no when they don't want something. They can use negation to express non-existent.
Alex, we've lost your audio.
Yes, apparently France has internet issues today. Hold on for a sec. And also maybe, Anne, if you're online, can you call Alex and see if he's got a connection coming up?
Yeah, I'm doing that.
Thanks for your patience, everyone. He's
can
back.
you hear me?
Hello, Alex. We lost your audio briefly.
Oh, okay. Can you hear me now? Sorry about that.
Yeah, I think it's
talking on the phone.
Yep.
Okay.
You were out for about 30 seconds a minute.
Okay, so basically what I was saying here is that we know that children are starting producing negation in their own speech at about 13 months, right? In many ways. So at the beginning, we thought, well, they might be able to understand negation as well, right? But recent studies investigating the understanding of negative sentences has actually found that 2 to 4-year-olds can have difficulties understanding negative sentences in certain tasks, right? And especially that before 2 years of age, children may lack an understanding of negative sentences, right? So basically in some experiments, they seem to do not distinguish between affirmative and negative sentences. And the question that arises is whether or not we might have a problem for language acquisition, because if there are situations in which children process a negative sentence as being an affirmative sentence, they would probably make incorrect associations between words and their meanings, because as you saw, children are learning words from the very beginning, right? So imagine someone says, oh, this is not a toy, and the child actually understands it, oh, this is a toy, so they can be in a very dangerous situation. So If you heard Jeff's talk yesterday and Anna's talk today, you are convinced that before the age of 2, infants are learning word meanings, and they exploit the syntactic and semantic context in which the words occur to learn their meanings, right? So you saw this experiment in which if you show a penguin cartooling and you say, oh, look, it's a dog, they believe that dog means penguin, right? And if they hear, oh, look, it's scratching, so they will learn that scratching means cartooling, right? We also have studies showing that they can use the semantic context as well to learn the meaning of novel words. So if they hear that Dax is crying, they believe that Dax is a kind of animate agent. But when they hear that Dax is right here, they don't make any guess about whether Dax is the animate or the inanimate agent here, right? So this is all great, but what we don't know exactly is how do children integrate negative elements in these sentences and whether they can actually process that as well, right? To learn the meaning of novel words. So when they hear a sentence not like it's not a dog or the duck is not crying, do they make any inference about what the novel word actually means, right? So and that's something that we don't know very well yet, but actually there are a bunch of studies in the word learning field suggesting that contrast information, so basically giving children explicit evidence concerning the limits of the application of novel words could have facilitative effects in word learning. So assuming to this, according to these studies, a child who still don't know what, for example, DAX means, could benefit from a situation in which they know what kind of objects can be called a DAX. So here we can show a Dalmatian dog and say, oh, this is a DAX, right? And what kind of animals cannot be called a DAX, right? So here, if you have, this is a DAX in front of a Dalmatian, then you see another type of dog and say, oh, this is not a DAX. Now you can refine your interpretation of what DAX actually is. And here, maybe DAX cannot apply to all kinds of dogs, but only to Dalmatians, right? However, the role of this kind of contrastive information may be limited and potentially harmful, as we saw that young children can have difficulty understand negative sentences in some contexts, right? So to investigate this issue, in this study, we asked whether English learning children can exploit negative sentences to restrict or refine the meaning that they associate to novel words, and whether they can retain the restrictive information provided by negative sentences as a cue to guide their interpretations. So in this study, to test this, we used a set of new objects coming from a continuum of novel creature-like objects. So this is a continuum of objects that was designed by Harvey and Waxman in 2016, and we were very grateful that they accepted to share their simile with us. So in here, in this continuum, you can see that we have a bunch of novel creature-like objects, and they change individually from one to another by varying a few features like color and shape. And they go from 0% until 100%. So we start with an object that's like pretty much yellowish, right? And keep changing until they go to 100%, right? And so our idea here is to test how negative sentences can influence children's categorization of objects that vary along a perceptual continuum. So to test this, we did a teaching phase in which participants would first be exposed to a few exemplars from the bottom part of this continuum. So here, very much yellowish objects, and they were all called blickets. Oh, look, these are blickets. So you see the blickets. So both participants in the affirmative and negative condition first got that information, that this kind of yellowish animals or monsters were called blickets. Then in the second video, the lady would show exemplars coming from the top part of the continuum. So here, pinkish animals, right? So, and in the affirmative conditions, she would say these are also blickets, right? But in the negative conditions, she would say, oh, these are not blickets, right? And what children should actually learn in this teaching phase? Well, in the affirmative condition, they first saw the yellowish animals, and they were always called blickets, right? And then in the second video, they see that the pinkish objects are also blickets, right? So they should form a single and overreaching category here for blickets, right? And therefore, blickets might be all elements that go from yellowish to pinkish in here, right? However, children in the negative condition, they will first hear the yellow, they would see the yellow object and they will hear, oh, these are blickets, right? But then when they see the pinkish object and the lady say, oh, these are not blickets, now they should restrict the category for blickets and therefore believe that blickets can only refer to a yellowish object and not all kind of objects in here, right? So in this task, we tested two populations. One is a group of 2 to 4 year olds, and those are, this is the age range in which children struggle in some of the past studies, right? But we also test a group of adults to give us a baseline on how children should behave in this task if they have adult knowledge about negation, right? So immediately after this learning phase, participants went to a test phase in which we had two types of trials. In the first trial, they would see novel exemplars coming from the continuum that I showed you before. So one that's coming from the bottom part of the continuum, so a yellowish object, and the other one coming from the upper part of the continuum, so a pinkish one, and they will be asked to find a blicket. Okay. Then they would go to two filler trials, just asking them with familiar nouns, so whether they can identify a dog or a cow, right? So, and then they had a second type of trial. So now let's say the test trial 2, in which we would show again a new exemplar coming from the upper part of the continuum, but they would see a completely unrelated object in here. And the idea is whether children will be, especially in the negative condition, they would be able to remember the information provided by negation before. And so that is that this kind of pinkish object cannot be a blicket. And then be forced to, oh, well, if this one is not a blicket, then maybe the unrelated object should be a blicket, right? So can then remember that information as well. So we had these two types of trials and 4 novel words in total. So I will very briefly show you an example of a child doing this task, and then you can understand very well how this works.
Oh, did you see what I have with me? These are my televisions, and these televisions are amazing. And guess what? We are going to watch some cartoons. Do you want to watch? So, let's go. Oh, these are blickets. Do you see? These are blickets. These are really nice blickets. Yes, they are blickets. Do you see these blickets? I like these blickets. Now let's see what we have on the other television. Oh, look, these are not blickets. Do you see? These are not blickets. They are really cool, but they are clearly not blickets. No, these are not blickets. Just look. You can see they're not blickets, right? But I love them. Now, let's play a game. Now, look. When you find a blicket, where is the blicket? Show me the blicket.
Now they see the two familiar trials.
Now look, can you find a blicket? Where is the blicket? Show me the blicket.
Okay, so got a better idea how this worked. So here are the results. I will show you the results by type of trial. So remember, in test trial 1, participants saw a yellowish object and a pinkish object, right? So the 20% and the 80%. And they were simply asked to find a blicket, right? In the affirmative condition, participants heard that both animals were members of the blicket category, right? But in the negative condition, only the yellowish object was the member of the blicket category, and the pinkish object was not a blicket, right? So what I will show you is the proportion of choice to each type of picture, right? For both adults and children, and in the negative condition, in the affirmative condition. So the bar in blue will be the proportion of choice of the 20% picture, and in red to the 80% picture. And so, as you can see, adults are very well behaved and performed at ceiling. So you can see that in the negative condition, they were 100% correct and only choose the 20% picture, so the yellowish one. But in the negative, in the affirmative condition, they were between the two, because of course that was expected. Both were members of the blicket category, right? And children behave pretty much like adults. So again, in the negative condition, we see that they had no problem at all in being more restrictive in their choice and only picking the 20% object, right? But in the negative, in the affirmative condition, they still had a little preference for the 20% option, but that's fine, because what we wanted to see is that they would select the 20% picture more in the negative condition than in the affirmative condition. That's exactly what we observed in the results. How about the test true trial, right? Which is when they were when they saw the member of the blicket for the affirmative condition, or not a blicket in the negative condition, against a completely unrelated object here, right? So as you can see, adults, they were forced to use a kind of mutual exclusivity strategy. So they choose without any problem the unrelated picture more in the negative condition than in the affirmative condition. And they were 100% correct in the affirmative condition, because they remembered that this one was also a blicket, right? So they picked that 80% picture all the time in the affirmative condition. However, children, while they were still fine, because they select more often the unrelated picture in the negative condition than in the affirmative condition, but they were not as good as adults in using the mutual exclusivity strategy in here, right? So we don't see a difference between these two bars, which suggests that we cannot say that they selected the unrelated picture more often in here, right? So they selected more than the children in the affirmative condition, right? So what we can conclude here is that preschoolers' success in our test suggests that they understood negative sentences, right? So we saw that English learning preschoolers can compute the meaning of sentences containing negation and use negative sentences as a tool to understand the boundary of a word's meaning. We have similar results in another type of task with 20-month-olds, showing that they are also able to understand negative sentences to learn the meaning of novel words. But in our task here, we even saw that children were able to remember the restrictive information provided by negative sentences when faced with a novel object, which was a member of the not blicket family, versus an unrelated object, right? However, they were not as good as adults in making the additional inference, namely that the other unrelated object should be a blicket. So previous failures in the literature testing the understanding of negation might not be due to a problem of understanding negation per se, but rather to the complexity of the task used or the context in which negative sentences were presented, right? Maybe it's not a difficulty in interpreting negative sentences per se, like A versus not A, we can see, and we saw in test trial 1, the children were perfectly fine in understanding the difference between the two types of sentences, but rather a problem in using the restricted information to make an additional inference in certain tasks, like when we ask them to go from, if not A, then B. So the contrasting information provided by negative sentences in our task helps children to discard the possibility that blickets refers to all creature-like objects. So we can see that this study provides direct evidence that preschoolers can take advantage of negative sentences to constrain the extension of a word's meaning, and negative sentences may therefore represent an important tool to constrain the acquisition of word meanings and to support language acquisition more generally. With all my co-authors and people who helped us in this project in the lab, I would like to thank you for your attention.
Thank you, Alex. We'll now turn it over to the Q&A. Again, there's a Q&A button on the Zoom if you want to ask a question. Our first question is from Gail Mauner. Apologies if I pronounce your name incorrectly. Gail asks, when the category of blicket was negated, the presentation also included non-linguistic cues for negation in terms of different facial expressions and a head shake. To what degree do you think that your preschoolers are relying on the linguistic cue for negation?
That's an excellent question, and I don't have an answer for it because we didn't try to disassociate all the different cues. We put everything we could in there, right, to help them. Otherwise, it should be weird to use a negative. So for example, if you just think about the prosody or the intonation of the sentences, I think it would be really weird to say negative sentences with exactly the same prosody of an affirmative sentence. So if you're denying something, you wouldn't say, oh, these are not blickets, right? So it would sound funny or weird or not pragmatically felicitous. So we did put everything we could in there. I should say that there is a paper from the Tomazello group in which they try to dissociate the cues like head nodding or saying no, or like, you know, like giving individual cues and testing whether each individually would help the younger children. I think they were around 2 years of age, and they didn't find that effect, right? So that's a good question, but we should do further studies, and actually maybe we should do, I will, to investigate what if, for example, you give exactly the same type of sentences, but not showing the lady anymore, pointing and doing all the visual cues and everything, would they still perform well in the task? And I guess they will, because at least the project will be there, right? But there are many other things that we could still investigate to see what exactly is helping, right?
Thank you. Our next question is from Roman Feynman. Feel free to unmute yourself.
Hi, Roman.
Hey, Alex. Really, really nice work, nice results. So I guess my question is just about whether with some kids, or in some cases, negation can make it harder to learn words, right? And I guess this is kind of a logical, in principle point, right? Which is that assuming that there's just some early age at which kids don't yet know what the words know and not mean, doesn't it just have to be the case that they misanalyze words that are under the scope of negation? So, you know, maybe that age is younger than the kids you test here, but it just seems to me like at some point that just has to be an impediment to identifying the reference of nouns and verbs.
Yeah, well, it's possible that that's, I don't know, very young infants might start with the wrong parser, or, you know, like not understanding it. I don't know if they ignore it or if they are completely confused, right? But it could be, maybe we do have an age in which they don't really understand, right? Or they are still learning it. With this, well, I remember when we did the symposium at BU, some people say, well, but you know, maybe they are, I think it was Jess's comment on that as well. Maybe they are just noticing that in one case you have, these are blickets, and in the other case, these are blickets, right? Because they have the not in there, and so they maybe just assume that there is something different. In this case, it's a nice example because we also had in the affirmative condition a new element that was also, right? So we cannot simply say, well, they are not really understand. They are just noticing that there is something different, right? Because in the two cases, there were something different in there.
Wonderful. We have about 2 minutes left. And a bunch of questions have just come in. So most of you are going to have to move yourself over to the discussion.
I'm happy to answer them in the discussion page.
Wonderful. So we'll just do one more. This is a quick read aloud. In the test session with a new object, this is from Eve Clark, you ignore the role of shape and categorization. The best answer here would actually be neither. Did any children fail to respond?
Well, sorry, I start reading someone's question at the same time you were talking. Sorry.
Oh,
Can you
sorry, no
repeat the
problem.
question?
So Eve Clark asks, in the test session with a new object, you ignore the role of shape and categorization. The best answer here would actually be neither. Do any children fail to respond?
No, we didn't observe this. No, they always pointed. We had in the perceptual continuum, some of them varied in color, some in shape, and we didn't observe any effect of trial or item, right? So,
wonderful. Thanks, Alex. So thanks everyone. For those of you who I didn't get to, apologies, but please do jump over to the discussion board where Alex will continue the conversation. If you also had questions for Anne, you can head on over to that discussion board and ask questions there and interact there. I want to announce that due to our few technical difficulties, we're going to start the next session 10 minutes late, so everyone will have a break. We'll start at 1:10 Eastern time. But thanks to both our speakers, Anne and Alex, and we'll see you all in the next session.